Billions of dollars have changed hands in just 2 years. Every major software platform, every digital workspace, and every interface has been rewritten to house the same invisible engine. We interact with it daily. We treat it like a simple search bar, a digital assistant that answers questions on command. But look closer at your screen. Most users see a seamless conversation. They do not see the architecture that makes it possible. They do not see the massive infrastructure vibrating behind every typed character. This is the disconnect of our time. We are living in a global surge of generative intelligence, yet we operate as if we are merely talking to a machine that thinks like a human. It does not. The reality is far more complex and far more mechanical. Today, we stop treating these tools as magic boxes. We stop accepting the surface-level output and start pulling back the layers. It's time to look past the chat window and understand the precise, calculated sequence that generates your world. We are going inside the machine. To understand the machine, you must first stop viewing AI as a single uniform object. It is a field of study as broad and specialized as medicine. Just as a surgeon operates differently than a pharmacist, generative tools function through distinct, rigorous architectures. We are narrowing our focus today to generative AI, the specific class of systems engineered to converse, summarize, and synthesize information. Forget the brand names for a moment. Whether you are interacting with a text-based chatbot or a sophisticated image generator, they share a common, hidden foundation. They all rely on the transformer architecture. This is the engine room of the digital age. It is the design framework that allows these models to handle complex data at an unprecedented scale. Without the transformer, there is no fluid conversation and no creative synthesis. It is the core, the structural skeleton that supports every large language model in existence. By identifying this architecture, we move past the illusion of the interface and start analyzing the physical logic of the system itself. This is where the true power of the machine begins to reveal its shape. When you type a prompt, you assume the model reads your sentence as you do. You are wrong. The model does not think in language. It possesses no concept of grammar, no appreciation for tone, and no inherent understanding of human intent. It operates on a cold, mechanical process called tokenization. To the machine, your sentence is merely a raw stream of data to be dismantled. Think of a long, complex word like anti-disestablishmentarianism. A human sees a concept, a historical movement, a single entity. The model sees none of that. It takes that word and shatters it. It breaks the string into several distinct, fragmented chunks of memory. These are tokens. Crucially, a token is not a word. Sometimes one word equals one token. Sometimes a single word is sliced into 4 or 5 separate units. The model does not process your input as a coherent thought. It processes it as a sequence of these small, numerical fragments. It slices your input into manageable pieces, strips away the human context, and prepares the data for its next internal stage. This is the first step of the transformation. Your language is gone, replaced by a stream of fragmented units waiting for the next phase of the architecture. Once the input is shattered into tokens, the machine performs a radical conversion. It maps each token to a vector. Imagine a vast, invisible grid, but not a simple flat surface. This is a multi-dimensional space, a coordinate system with thousands of axes. Every token is assigned a unique string of numbers that places it at a specific point in this digital landscape. Think of it like a map of the world where proximity represents meaning. If you place the word king at one coordinate, the word queen will appear at a nearby point, while bicycle will be plotted thousands of miles away. The model does not see the word. It sees a list of coordinates, a distance, and a direction. This is how the engine calculates relationships between concepts. By measuring the numerical distance between these points, the system determines which ideas are connected and which are unrelated. It is pure geometry. The machine is not debating definitions. It is calculating trajectories in a high-dimensional void. Every concept you type is translated into a precise numerical signature, effectively turning your language into a map of mathematical relationships. This is the foundation of the model's intelligence. It navigates the human experience through the cold, precise language of coordinates and distance. Now, we encounter a fundamental failure in the system. If every token is assigned a static set of coordinates, how does the model handle the chaos of human language? Consider the phrase "took a hit." In the context of a golf course, that is a stroke. In a dark alley, it is a violent impact. In a recording studio, it is a chart-topping song. The coordinates for hit are locked in a fixed position, yet the meaning shifts violently depending on the surrounding words. If the machine only sees numerical proximity, it should be blind to these distinctions. It should see hit and provide a generic, confused average of every possible definition. This is the crisis of ambiguity. The model faces a wall of potential misinterpretation every time it encounters a common term. It cannot rely on a dictionary, and it cannot guess. It must somehow look at the entire sentence at once, weighing every word against its neighbor to lock in a specific, accurate interpretation. But how? How does a sequence of cold, mathematical vectors suddenly gain the awareness required to distinguish a punch from a melody? The answer lies in a mechanism that does not just read words, but actively reshapes them based on the company they keep. The solution is attention. It is not a passive process. It is a dynamic, multi-layered conversation between tokens. When the model processes the sentence "took a hit," the token for hit does not stand alone in its static coordinate. Instead, It reaches out to every other token in the sequence. It looks at took, it looks at the surrounding context, and it begins to shift its own vector. Think of it like a web of gravity. The token golf nearby exerts a pull, dragging the coordinates of hit toward the meaning of a stroke. The token boxing pulls it toward the meaning of a strike. The attention mechanism calculates these weights simultaneously across the entire sentence, effectively updating the definition of every word based on its partners. It is a constant, real-time recalibration. The machine is not just reading a sequence. It is seeing the connections that bind words into intent. The ambiguity vanishes because the word is no longer fixed in a vacuum. It is defined by the company it keeps. This is the definitive moment the machine gains its clarity. It does not just store language. It understands the shifting landscape of human expression by letting every word redefine itself through the lens of its neighbors. This is the core of modern intelligence. Attention provides the context, but the sheer computational weight happens in the engine room. This is where feed-forward neural networks take over. Functioning like a massive hyperspeed synthesis engine, imagine taking a mountain of raw, disorganized research notes and boiling them down into a single razor-sharp business strategy. This process is not sequential. It happens across thousands of tiny cores simultaneously. This is the realm of the GPU. While a standard processor might tackle tasks one by one, these chips handle the entire web of vectors at once. They are the reason the machine responds in seconds instead of years. As the data passes through these layers, the model filters out the noise, consolidates the relationships forged by attention, and discards the irrelevant pathways. It is a relentless distillation. Every layer of the network tightens the logic, pushing the data toward a singular, cohesive result. It is not just doing math, it is building a structure. By the time the information clears these parallel processors, the raw, chaotic input has been transformed into a logical, organized output. The machine has bridged the gap between scattered data and human-like insight through sheer, unrelenting computational throughput. The synthesis is complete, and the model is ready to speak. With the synthesis complete, the model shifts into the final gear, the decoding phase. This is the moment of creation. The model does not simply dump a pre-written file. It builds the response one token at a time. It looks at the massive, consolidated vector state it just produced and asks a single question: what comes next? It generates a probability distribution for every possible word in its vocabulary. It might see a 90% chance for one word and a 10% chance for another. It picks one, adds it to the sequence, and then loops back. This is the critical feedback loop. The new token becomes part of the input, changing the context for the next calculation. The model reruns the attention and feed-forward layers for this updated string, constantly refining its direction. It is a relentless, iterative dance of prediction. It generates, evaluates, and adjusts, moving toward the finish line of the response. With every cycle, the machine narrows the vast ocean of possibilities down to a single, coherent string of language. It is a process of constant collapse, where uncertainty is replaced by specific, calculated output. When the model hits the final stop token, the loop breaks. The conversation is complete. The transformation from raw, multi-dimensional data into a fluid, human-readable answer is finished. Now that you understand the machine, you must realize that the machine only knows what you tell it. Your prompt is the steering wheel for these deep, complex mathematical loops. If your instructions are vague, the model explores a massive, undirected space of possibilities, leading to generic results. To change this, you must adopt the RACE framework. Start with role. Tell the model exactly who it is, whether a senior analyst or a creative consultant. Next is action. Be precise about what you need the machine to perform. Follow this with context. Provide the necessary background to narrow the vector space and sharpen the focus. Finally, include an example. Show the model the style or format you expect to see. This structure is not just a suggestion, it is a tactical constraint. By defining your role and the desired outcome, you force the model to prune irrelevant pathways and concentrate its processing power on your specific needs. Stop treating these tools like a simple search bar. When you apply the RACE framework, you stop being a passive recipient of whatever the machine decides to output and start directing the logic. You provide the intent, and the model provides the execution. This is how you reclaim control over the interaction. The power of this technology extends far beyond simple text chat. We are currently witnessing a massive migration of these same core principles into the bedrock of global infrastructure. In finance, models are now parsing millions of transaction patterns to detect anomalies in real time, using the exact same vector-based relationships we have explored. In logistics, these engines optimize complex supply chains by calculating attention across thousands of variables, predicting disruptions before they manifest physically. Whether you are managing a portfolio or a warehouse, the machine is performing the same mathematical dance. The underlying architecture is indifferent to the subject matter. It only cares about the quality of the data and the precision of the prompt. You no longer have to be a spectator to this shift. By understanding the mechanics of tokens, vectors, and attention, you have moved from a passive consumer to an informed operator. You have the map. You understand the engine. Now, apply these fundamentals to your own field and start driving the outcome. The landscape of the future is being built in multidimensional space, and it is waiting for your input. If this deep dive helped you understand the machine behind the screen, hit that like button and follow for more.